Today the topic for discussion is numerical integration, and this is the next chapter, numerical integration and numerical differentiation. So we are going to observe numerical integrations and the formulas used to find numerical integration of the function. So the first one is what? General quadrature formula. So the question is state and prove the general quadrature formula for numerical integration. And this is the statement of the general quadrature formula. Consider integration a to b fx dx denoted by I. So we have to solve this integration a to b fx dx by using the numerical integration. We have to solve this integration by using numerical integration. Let this interval AB, this interval of integration, be divided into n equal subintervals or n sub parts. Then each of length is what? Length of each interval is what? H is equal to b minus a divided by n. B minus a divided by n is the length of each interval. For example, if we divide the interval 1 to suppose 5 in 4 interval, then what is the length of each interval? 5 minus 1 divided by 4, that is 1 is the length of each interval. So how we calculate the length of interval? B minus a by n. N is what? Number of sub intervals or number of sub parts. And then this interval AB divided into n sub intervals, and the end points of that n sub intervals are what? The first point is a or x naught, is denoted by x naught, is a, and next point is what? X naught plus h or a plus h, and is denoted by x1. That is the sub intervals, end points of sub intervals. X1 is what? X naught plus h, because h is the length of the sub interval, each sub interval, and therefore we obtain the next end point of the sub interval by adding h, and previous point by subtracting h. So x naught is a, x1 is a plus h or x naught plus h, x2 is what? A plus 2h, and in this way the xn last point is what? X naught plus nh is equal to b. So these are in n plus 1 numbers, because the intervals are n, but the points, end points are n plus 1 in numbers. This is the first point, this is second, this is third, that x2 is third, and means xn is what? N plus 1th point, and therefore these are the end points of that sub intervals. So h is the length of each sub interval, and therefore we have these points x0, x1, x2, xn. So these a plus h, a plus 2h, a plus nh are all the values of x and are what? Equidistant. These points are equidistant. And then let f of xn is equal to yn. That is what? F of x naught is y naught. What is the notation? F of x naught is y naught. F of x1 is what? Y1. That is the value corresponding to x naught is y naught. The value of the function fx or y is what? Y naught. The corresponding to value corresponding to x1, the value is y1 or f of x1. Then corresponding to x2, the value is y2 or f of x2. In this way, the corresponding value of xn of y is what? Yn. So corresponding to x naught, value of y is y naught, and the value at x1 is y1, and in this way. So this is the formula. F of xn is equal to yn means what? For all n runs from 0, 1, 2, 3 means what? The value corresponding to x naught is y naught, corresponding to x1 y1, x2 corresponding to x2 value is y2, and so on. And then this I or integration a to b fx dx is equal to what? H in bracket n y naught plus n square by 2 delta y naught 1 by 2 factorial. Y naught means again f of x naught or f of a, n square by 2 delta f of a 1 by 2 factorial, n cube by 3 n square by 2 delta square y naught, and in this way 1 by 3 factorial n raised 4 by 4 minus n cube plus n square delta cube y naught plus so on up to n plus 1 terms, or just write plus so on dash 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 dash. So this is the formula called general quadrature formula. So this is the statement of the general quadrature formula. Then proof of the general quadrature formula. So consider the integration a to b fx dx and divide this interval ab into n sub intervals, and each of length h is equal to b minus a divided by n, the length of each sub interval. Then take x naught as a, x1 as x naught plus h, that is a plus h, then x2 as x naught plus 2h. In this way xn is x naught plus nh, and f of xn is what? Yn, means f of x naught is y naught, f of x1 is y1, f of x2 is y2. In this way f of xn is yn for all n runs from 0, 1, 2, 3. And we consider this integration a to b fx dx and put x is equal to x naught plus hu. That is the variable change, the x variable converted to u, new variable, that is integration by substitution. What is the substitution? X is equal to x naught plus hu, or x is equal to a plus hu. So write either x naught or a. So what is the substitution? We will solve this integration by using substitution method. So x is equal to x naught plus hu is the substitution, and therefore dx is equal to its derivative. Derivative of x naught or a is 0 and h is constant, but the derivative of u is what? U is variable, so its derivative is du. So dx is h du, and these limits are changed. What are the limits? Original limit x is equal to a. So if we substitute x is equal to a in this formula, so what do we have? A minus this x naught means a minus a. If we substitute x naught in LHS, then what do we have? A minus a, that is 0 is equal to hu, and therefore u is 0. So as x is a, u is 0, and when x is b, that is substitute here this x as b. So what is b is equal to, this is x naught means a plus hu, and then b minus a is equal to hu, means u is what? Means u is what? Substitute x is equal to b. So b minus a, what is the value of b minus a? Is nu, b minus a, divided by hn. The value of b minus e is hn, and therefore divided by h means the value of u is n. So if we substitute here x is equal to b, then what we have? b is equal to a plus hu, that is b minus a is equal to hu, and b minus a is n into h. So divided by h means what? We have u is equal to n. So when x is b, u is n. When x is a, u is 0. So therefore this integration becomes I is equal to integration 0 to n. Instead of a to b, write 0 to n, because if x is a, u is 0, and if x is b, then u is n. So we have the integration limit 0 to n, f of, and the value of x is what? X naught plus hu, or a plus hu, into dx is what? Dx is h du, and then this h is constant. So take out of this limit h, integration 0 to n, f of x naught plus hu du, and then expand this f of x naught plus hu by using Newton's forward interpolation formula. So what is the forward interpolation formula? Newton's forward difference interpolation formula is this: f of u plus a plus uh is what? The expansion is f of a plus u delta f of a plus u minus 1 by 2 factorial delta square f of a plus u minus 1 u minus 2 by 3 factorial delta cube f of a, and so on. So here the notation are what? This is x naught, f of x naught, instead of a, the notation is x naught plus hu. So f of a plus or hu is what? The expansion by using this, the expansion of this term, f of x naught plus hu, the expansion is what? This is the expansion, f of x naught, this term f of a, u delta f of x naught, then u minus 1 by 2 factorial delta square f of x naught So here x naught is a is x naught in this formula. So next term is plus u minus 1 u minus 2 by 3 factorial delta cube f of x naught, and plus so on up to n plus 1 terms. Right here up to n plus 1 terms, or just write plus dash 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 du. So this bracket value of this by using Newton's forward interpolation formula is this bracket, and this integration 0 to n, this h integration 0 to n du as it is, h integration 0 to n du as it is, and the expansion of that quantity f of x naught plus hu by using this Newton's forward interpolation formula is this. So right here reason right to the right side of the step. Then next step, so h as it is, integration 0 to n as it is. So f of x naught means y naught. What is the notation here? F of xn is yn means f of x naught is y naught. So right here new notation that f of x naught is y naught. Similarly here f of x naught is y naught, f of x naught is y naught, and this f of x naught is y naught, and up to n plus 1 term. So just from this step to this step, just write f of x naught as y naught, new notations. Then next step, and this simplification. What is the simplification of u into u minus 1? Use u square minus u. What is the simplification of these three terms? Multiplication of these terms. First multiply these two terms. What is the multiplication of these two terms? U square minus 3u plus 2, and then multiply by u. So u cube minus 3u square plus 2u by 3 factorial, multiplication of this. And then we are going to integrate this bracket with respect to u. So what is y naught? Integration of y naught. Y naught is constant with respect to u. So its integration is y naught into u. This y naught into u. The first term, integration. Integration of y naught with respect to u is what? Y naught into u. This delta y naught is constant. Integration of u is what? U square by 2. So u square by 2 delta y naught. Then next step is 1 by 2 factorial. This 1 by 2 factorial. And the integration in bracket, the integration of u square minus u. Integration of u square is u cube by 3 minus u square by 2. U cube by 3 minus u square by 2. Delta square y naught as it is. This delta square y naught as it is. Then 1 by 3 factorial. And the integration of this quantity in bracket is what? U raised to 4 by 4 minus u cube by 3. 3 get cancelled, means minus u cube, plus u square by 2. So u 2 get cancelled. So what is the step? 1 by 3 factorial, u raised to 4 by 4 minus u cube plus u square, this delta cube y naught, and so on and so on. And the bracket is completed because the integration is what? Definite integration. So what is the integration? Is integration from 0 to n. So write all these terms in square bracket, and then limit is what? 0 to n. This is definite integration. So limit 0 to n, and then substitute find the value of this bracket at n minus value of this bracket at 0. That is, first substitute u as n. Substitute u as n. So what do we get? We get this step. Cancel this step. What do we get? From this step, write this step. So h u y naught. Substitute u as n. Here substitute u as n. So write what we have? We have n. Don't write these two steps. Directly observe this step, last step. So write or find the value of this bracket at n. So what is the value? N y naught plus n square by 2 delta y naught plus 1 by 2 factorial n cube by 3 minus n square by 2 delta square y naught 1 by 3 n raised to 4 by 4 minus n cube plus n square delta cube y naught, and so on up to n plus 1 terms. So this is the value of this bracket at n. That is, substitute first u is equal to n, then minus the value at the lower limit, that is substitute u as 0. So if you substitute u as 0, then this term is 0, this term is 0, this term is 0, this bracket is 0, and that is all the terms are 0. So no need to write minus lower value at lower limit, because we have the value at lower limit. That is, if you substitute u as 0, then we have the value 0. And so from this step, ignore these two steps, cancel these two steps, no need of these two steps. Directly from this step, write this step. So what is the step? That substitute u as n, or find the value of this bracket at upper limit minus the value at lower limit. So value substitute u as n, we get this, minus if we substitute u as 0, then we have the answer 0. So, and this is what? This is the general quadrature formula. This is the general quadrature formula. So we have this general quadrature formula, and this is the statement of the general quadrature formula. This is the statement of the general quadrature formula, that the last answer in the proof is the statement of general quadrature formula. So next is the trapezoidal rule. So by using the general quadrature formula, we are going to prove 3 rules. First one is trapezoidal rule, second is Simpson's 1/3 rule, third is the Simpson's 3/8 rule. So all these rules are used to obtain the numerical integration. So question is state and prove trapezoidal rule for numerical integration. So statement of the trapezoidal rule: consider the integration a to b fx dx denoted by I, and again divide this interval ab into n sub intervals, each of length what? B minus a divided by n, that is the EH denoted by H, length of each sub interval. EH is equal to b minus a by n. So divide this interval a to b in n equal sub intervals or sub parts, and each of length is what? B minus a by n, and then x naught is a, that is, these are the n points of that sub intervals. First is a, then a plus h, or x naught plus h, x naught plus 2h, x naught plus nh, that is the last point is b, that is xn or x naught plus nh is b. So these are the n sub intervals, and f of xn is yn at n is equal to, for all n is equal to 0, 1, 2, 3, means what? F of x naught is y naught, f of x1 is y1, and so on. And then integration I is equal to integration a to b fx dx is equal to h by 2 in square bracket y naught plus yn, that is first point plus last point in the first bracket, plus 2 times y1 y2 y1 plus y2 plus y3 plus y4 plus yn minus 1, that is the 2 times of the addition of remaining, that is the in the first bracket the first value of the function and last value of the function plus 2 times the remaining. So this is the statement of trapezoidal rule. Then proof of the trapezoidal rule. So first state the general quadrature formula. In order to prove the trapezoidal rule or Simpson's 1/3 rule or 3/8 rule, first in proof write the general quadrature formula. So consider this integration, divide this interval in sub intervals, each of length b minus a by n, and then these are the end points of the intervals, sub intervals. Then these are the values of function at that x0, x1, x2, xn, and then general quadrature formula is what? I is equal to h n y naught plus n square by 2 delta y naught plus 1 by 2 factorial n cube by 3 minus n square by 2 delta square y naught, and so on. So this is the general quadrature formula. Then the first one is the proof of trapezoidal rule. So put n is equal to 1 in this formula. Put n is equal to 1 in this formula. So if you substitute n is equal to 1, then what are the n points? What are the number of sub intervals? That x0 is a, x1 is a plus h. That is if n is equal to 1, then what? The interval of integration will be x0 plus to x0 plus h. That the interval of integration. What is the interval of integration? A to b. But a is what? A means x0. B means what? B means x0 plus nh. But if we take n as 1, then what do we have? The sub intervals are, number of sub intervals is 1. Only this is the interval of integration x naught to x naught plus h, because n is 1. So last point is what? X naught plus h, that is b is x naught plus h. So then their corresponding values of y are what? The values at x naught is y naught, and the value at x naught plus h means at x1 is y1. So the value of y or the function fx are only 2, y naught and y1. And therefore, if the values of x or the values of y are 2 in number, then what is the last column of the forward difference table? We know that it is delta y naught or delta fx is the last column of the table. And if there are 3 values of x or the 3 values of y, function y, then what are the last column of the table is what? Delta square y naught or delta square fx, and further differences are 0. Here only 2 values of x. What are that? X naught and x naught plus h, and the corresponding value of y are only 2, y naught and y1, and therefore only the difference of first order is non-zero, and the difference of the second order, third order, all are 0, because the values of x or y are 2 in number. So we have only these terms, up to these terms. And so what is I? Is h, n, value of n is 1, substitute n. So y naught plus 1 square by 2, that is 1 by 2 delta y naught. So we have this I is equal to, I means what? Integration x naught to x naught plus h, because n is 1. I is what? Integration x naught to a to b means what? X naught. A means x naught, and b is what? Here b is what? X naught plus h, because n is 1. So integration I is equal to integration a to b means what? X naught to x naught plus h fx dx is equal to here I means value of I is what? X naught to x naught plus nh. Instead of that, what we have? X naught to x naught plus h fx dx is equal to h in bracket y naught plus 1/2 delta y naught. And the further differences are, what is the value of delta square y naught, delta cube y naught? All are equal to 0, because the values of x or y are in 2 number. There are only 2 values of x or y, and therefore all the further differences are 0. And therefore we have this form, general quadrature formula, that the value of I is what? A to b fx dx means x naught to x naught plus h fx dx, because x naught means a, and xn is what? Or b is what? X naught plus nh, but n is 1. So x naught plus h is b. B is equal to x naught plus h. So x naught to x naught plus h fx dx is this h y naught plus 1 by 2 delta y naught, and then h by 2, take this 1 by 2 as common. We have 2 y naught, that is multiply 1/2, take 1/2 as common means multiply the bracket by 2. So 2 y naught plus 2 by 2 1 delta y naught, and then the simplification of this delta y naught is what? Delta y naught is y1 minus y naught, and then 2 y naught minus y naught is y naught, and the effect of, then what do we have? We have this y naught plus y1. The value of this delta y naught is what? Y1 minus y naught, and so 2 y naught minus y naught is y naught plus y1. Okay, and therefore we have the value of integration x naught to x naught plus h is what? H by 2 y naught plus y1. Then take the next interval. What is the next interval? X naught plus h to x naught plus 2h. The next interval, x naught plus h to x naught plus 2h. So take this interval. So in the first, the interval is x naught to x naught plus h. Instead of this, take the interval x naught plus h to x naught plus 2h, and the value corresponding to x naught plus h or x1 is y1. the value correspond to x0 plus 2h is then y2. So these corresponding values are y1 and y2, and therefore we have, instead of this y0 we have y1, and here instead of y1 we have y2. So we have x0 plus h2 x0 plus 2h is h by 2 y1 plus y2. Then consider the next two intervals. If we consider next two intervals, next interval, not two interval, one interval, what is that? x0 plus 2h to x0 plus 3h. It is what? Fx dx is h by 2 y2 plus y3. In this way, the last interval is what? x0 plus n minus 1 h2 x0 plus nh. Last interval is what? x0 plus n minus 1 h, that is the previous point of this xn, x0 plus n minus 1 h to x0 plus nh, and it is equal to what? H by 2 yn minus 2 plus yn, because the corresponding value of y at x0 plus n minus 1 h is what? Yn minus 1, and the corresponding value of x0 plus nh is what? Yn. And then adding all these above steps, or we use this rule, integration a to b fx dx is and plus integration b to c fx dx is what? A to c. A to b plus b to c is a to c. Like that, if we add the integration a to b plus b to c plus c to d, then it is a to d, integration a to d. So the rule of addition of integration, so I is equal to integration a to b fx dx is what? Integration from a to, or x0 to x0 plus h, x0 plus h to x0 plus 2h, plus so on, x0 plus n minus 1h to x0 plus nh. That is, we have, if you add these all integrations, then we have the answer a to b, that integration a to b, that is this answer, because of this rule, that a to b plus b to c is a to c. Like that, a to b plus b to c plus c to d is a to d. So by using this rule, we have this step, that integration a to b is divided into these n subintervals by using this rule, that a to a means what? x0, x0 to x0 plus h, x0 plus h to x0 plus 2h. In this way, x0 plus n minus 1h to x0 plus nh, and then substitute the values of these quantities, this integration. So what is the integration? x0 to x0 plus h fx dx is h by 2 y0 plus y1, plus the value of this integration is what? H by 2 y1 plus y2, plus in this way the value of this integration is what? H by 2 plus yn minus 1 plus yn, and then take this h by 2 as common. What we have in the bracket? Y0 plus y1 yn, these are the single terms, and this y1 plus y1 becomes 2 times y1, and this y2 plus, then next term is again y2 is 2y2. In this way, this yn minus 1 and the previous term yn minus 1 becomes 2 times yn minus 1. Take that 2 as common factor, and therefore we have this 2 y1 plus y2 plus y3 plus y4 plus yn minus 1. That is what we have the answer, integration a to b fx dx h by 2, first point, first value plus last value plus 2 times remaining values. So integration a to b fx dx is what? H by 2, first value plus last value plus 2 times the remaining values, that is remaining are what? y1 y2 y3 yn minus 1. So this is the Newton's this is the trapezoidal rule, and in next lecture we are going to see the Simpson's 1/3 rule and 3/8 rule by using same process, that is by using the trapezoidal rule. So next lecture we will see the remaining two formulas.